So today we're going to cover section 5.1, two equations, two unknowns, something that a lot of you are familiar with. You've had this in high school. You may have even had it in a previous math course other than that. But there are going to be times where we're going to be able to write two equations and two unknowns. Now, on Facebook, you see a lot of these, but instead of X's and Y's, they're doing a cookie with 2 chocolate chips and a flower with 6 petals, those kind of things. Well, they're the same problem. Instead of X and Y, the unknowns are the chocolate chips and, that kind of thing. So we're going to start by taking a look at two equations, two unknowns, and simply say, is this ordered pair, -3, 5, a solution to both of those? Well, I'm going to back it up a little bit, and I'm going to say this is really the second one. If I subtract X and divide by 5, I'd have Y equals 3. I subtracted X and divided by 5. It's what we call a linear equation, right? If I look up here, it's linear because when I graph this, it's a line. And when I graph two lines, I know my choices are those lines cross somewhere or those lines are parallel, meaning they don't cross. And that point at which they cross is called the solution. So we're trying to find out, is this a solution for both of these? Meaning, if I graph these two lines, is that point where they cross? So if I plug in -3, I get -6 plus 30. That does in fact equal 24. If I plug in -3 in the next one, I get -3 plus 25. And that is not equal. And that would not be a solution for both of those. So this thing where I have two equations, two unknowns, starts to get into called a system of equations. So when it says, when we read all this terminology, determine if the ordered pair is a solution to the system. It is for the first one, but not so much for the second one. If I jump over to problem number 2, 0 for X, 1/2 for Y. Yes, that one does work. 0 for X, 1/2 for Y. And that one works as well. That one works as well. So this number 2, the two lines actually cross. This number 1, they don't cross anywhere. We say they're parallel. So I have a little paragraph here that says one unique solution. We just talked about that, where the two lines cross. No solution, it's when the lines are parallel. And there's also the possibility that the two lines are the same and every point would work. And every point, in fact, we come up with a term that you hear sometimes, and as soon as we're done, you'll forget it, because most people do, but they're dependent on each other, right? They're dependent. So a little bit of lingo going on in here. So how do I solve systems of equations? Well, there's a couple of methods. The first method is this guy right here, substitution. Okay, substitution. Substitution says I can take one of the equations, get a variable alone, and then plug it into the other equation to see if it's true. All right, so I'm looking at these two equations and I'm going to go, okay, in that second one, here I have 2x plus 3y equals 10. In the second equation, I'm going to get the y alone. I'm going to add it to the other side. I'm going to add 26 to this side. And I should have 5x plus 26 equals y. So what happens here is I'm combining these two. It's kind of odd, but I'm going to combine these two equations by saying, okay, I know what y equals in this second equation. So I'm going to go and plug it into the first. And when I plug it into the first, I get 2x plus 3 times 5x plus 26 equals 10. And what I did by combining those two equations was I eliminated one of my variables. I eliminated the y. Oh, yeah? Yeah, I did. So by substitution, I eliminated. Now I have one equation. I can go and calculate what x is. Once I know what x is, I can quickly find what y is, giving me the ordered pair for both. 2x plus 15x, plus, oh man, 78 equals 10. This gives me 17x. I'm going to subtract 78, so that gives me negative 64. Excuse me, 68. Whoo! Divide by 17, I find that x equals negative 4. That's a 4-point question. I just earned 3 of the 4 points. Why? Well, I know what x is. I now have to find y. So I'm going to plug it into this equation up here. 5 times negative 4 plus 26 equals y. And y equals 6. Ta-ta! What I get is the ordered pair negative 4, 6. That's going to work for both equations. So I figured a way to combine them. You're going to see that's a common theme, combining these equations. Are there any questions? Okay, good. Addition method. Addition method. See if you can remember the addition method. That means I would take this line, take its left side, add it to this left side, its right side, add it to this right side. Well, right now, if I add them, I get 7x, 2y, and negative 16. And nothing happened. Nothing happened. But what if I took this second equation and multiplied both sides by 3? Why did you pick 3? Well, let's see. Plus 3y equals 10. 15x minus 3y equals negative 72. Well, yeah, the multiplying everything by 3 is nice because I'm now going to eliminate one of my unknowns. When I take the left side and add it to this left side, the right side, add it to that right side. And again, this isn't 72, it's 78. I'm a little slow here today. 17x, the y's, they're gone, equal negative 68. X equals negative 4. Now I need to calculate y. I'm just going to grab that first equation. 2 times the negative 4 plus 3y equals 10. Negative 8 plus 3y equals 10. Whew, some of you are going, yeah, I got it. I'm good. I remember doing this. And that's awesome. Questions? No. No. All right. Number 5. I don't like working with decimals. So I'm going to take everything in the first row and multiply it by 10. That's going to give me a new equation, 50x plus 3y equals 14. More than legal. Second equation, Uh-oh, I need to go by not 10, but by 100, because I'd like that guy to be cleaned up. So I'm going to multiply everything in that row by 100. Now I have 20x minus 10y equals 28. Huh. Okay, not so bad. Not the best situation. Now I have to get rid of something. I need to either clear the x's or clear the y's. Anybody have any ideas? Anybody? Bueller. Pick one, X or Y. Just pick one.
Y.
Because I want you to. Sorry. Okay. So the Y's, I'm now going to start thinking of multiples. And I think if I go to 30 and 30, they would cancel. I'm going to multiply this one by 10 and this guy by 3. It's a little bit extra work. 500x plus 30y equals 140. Times 3. 60x minus 30y equals 84. For real? Everybody's watching my work, making sure I don't screw this up, right? Yeah. Okay.
Yep, watching.
Well, good, good. 60 and 30 and 84. Now I add 560x equals 224. Well, yeah, I'm allowed to get something that's not a nice number. You know, I can now simplify this, convert it to a decimal. I have a lot of choices. I'm going to divide everything by 2. I'm going to divide by 2 again. I can go by 2 again. 28 and 70. I'm getting somewhere. By 2 again. 14 and 35. I can divide by 7. I get 2/5. Okay, that's not so bad. 2/5. Now that I know x, I can take this and plug it in to any of these equations to try and find y. Plug it into any of them. There's 6 choices. It's going to work for all 6. We need to find one. Tell me where you would like me to stick it. Which equation? The first? Well, that's not so bad. Let's go with the first. 5 times 2/5 plus 0.3y equals 1.4. That becomes a 2. I subtract 0.3y equals negative 0.6. I divide, and I think I get y as -2. Oh, no, I ran off the page. I got y as -2. And I like that answer. Questions? All right, number 6. Number 6 just says solve. Number 6 says solve. Do you have a preference? Which method you want to use? I think I know which one I might use. we had substitution, and we had elimination by addition. Yeah, I eliminated a variable by adding the two rows. So that's why it's given the name elimination by addition. I think I might do which method?
Substitution.
Yeah, I'm going to try substitution. So go ahead and give that a try and see what you can come up with. Is Ella here today? Oh no, Ella just lost her perfect attendance. So let's see, I know what y equals. So 2x plus 4 times that y. Two x plus 20x minus 7 equals 4. Keep an eye on me. This is unlike me not to have a boo-boo by now. 22x equals 11x equals. I got 1/2. Hey, boo-boo. I'm going to plug it into that first one. 2 times 1/2 plus 4y equals 4. That becomes just a 1. 4y equals 3. Y equals 3/4. Believe it or not, I have a lot of students who'll take a test. They'll go through all of this work and they'll calculate the x and be done. They'll forget to do the y. Don't you forget about me. We good? All righty. Okay, I have a page with 3 more problems on. All of these have been working out so far. So I'm willing to bet one of these is going to be a problem that has no solution, and one's probably going to be an infinite solution, just because that's how they play the game. They talked about 3 possibilities, and I'm thinking one of these may be in that category. So you can see number 7 and number 8. I'm going to give you a couple of minutes to try it. I'm going to pause the recording. So the first thing I did for number 7 is I got the equations into a better form, that x plus y equals c. And that actually has a name. That's standard form for linear equations. X plus y equals c. So we start out distribute. 3x minus 3 plus 10 is negative y. I'm going to add y. And I'm going to subtract 7, and I have an equation. Good. Second equation, I distributed away. I added 30. I subtracted 4x, and I have something that looks like that. So we're just seeing variations off of what we started with today, and that is solving these 2 linear equations. And couple different choices here. Elimination by addition, or I could do substitution because I have a nice little y there. I send a 3x over and I would be good to go. Anybody have a method they used? Because I'll use whatever somebody says.
Substitution.
Substitution, fantastic. I'm going to take this fella and I'm going to make it y equals negative 7 minus 3x, and I'm going to plug it into that equation. Got the y alone, solved for y. Plug it in. Negative 4x plus 6 times negative 7 minus 3x equals 2. I take my time sometimes and double check because you know me. Negative 4x plus negative 42 minus 18x equals 2. Combine the x terms. I'm going to add 42. Yay. X equals negative 2. I know right where I'm going to plug that. I'm going to plug it right into there so that I can say y equals negative 7 minus 3 times negative 2. Y equals negative 1. Can I get a thumbs up if that's what you got for the answer? Jesse says thumbs up. Caitlin says thumbs up. All right, I got a couple of thumbs up. It's a bunch of work. It's more organization than anything. You know, becoming organized, getting the equations that you want, doing the work over here on the side to get them into what I want, then picking which method to use. Number 8, I'm guessing substitution is going to be the choice of flavor here. 10x minus 5 times 2x minus 6 equals 30. Equals 30. Uh-oh. The x terms cancel. They're gone. The numbers cancel. I end up with 0 equals 0. What does that mean? Well, this guy was y equals 2x minus 6. This guy, if I solve for y, okay, I get negative 5y equals negative 10x plus 30. I subtract the 10. I divide by negative 5, and I get y equals 2x minus 6. They were the exact same equation. So this is, if they're the same equation, infinite solutions. To infinity and beyond. Any questions?
Infinite solution and no solution. What's the difference?
So this is infinite solution. If this would have ended up as 0 equals 6.
Oh, yeah, that's no.
Right.
Okay.
That would have been no solution. Yeah. Well, we did one with decimals. We might as well get ready and do one with fractions. And this topic of clear the denominator comes into play. I'm going to take the first row and multiply everything in the first row by 3. I'm going to take the second row, multiply everything in the second row by 2. See what equations I get. I get 3x plus 5y equals 1. I get 3x. I get plus 5y equals 4. Yeah, this is one that is going to be no solution. Okay, that means the lines are in fact parallel. This is what we were just talking about a minute ago. Say I multiplied everything in the second row by a negative 1, and I added them. There'd be no x, there'd be no y, but over on this side, I'd still have a number. So that's my example of getting no solution, meaning they're parallel. This guy up here, like we said, is the same line. Same line. Let's just do one at a time. Wow, 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 wow. Thought this was math class. Way too many words. Well, let's take a look at it. Maybe we can break it down. David borrowed a total of $10,000 to pay for his final year of grad school. He borrowed part of the money through his Perkins loan and the remainder of the money from his aunt. So the Perkins loan, you know, we have something going on with the Perkins loan. We have his aunt. Okay. He borrowed money through school with a Perkins loan that charged 5%. Simple interest per year, and the remainder of the money from his aunt, who's charging him 1.4%. Okay, simple. At the end of the year, he paid $428 in interest. How much did he borrow from each source? How much did he borrow from each source? So I'm thinking the Perkins loan, you know, we need to figure out which one we want to be X and which one do we want to be Y? So let's see. I'm going to say, all right, so I got something going on like this. I'm going to say X equals the amount borrowed from Perkins, not the breakfast place. Y is the amount from his auntie. And I know those two amounts have to add together to be $10,000. Okay. Now, the interest part of this, 5% of the amount of the Perkins, 5% of is times Perkins plus 1.4% of his auntie has to equal $428. Here's a nice clean equation. The amount from Perkins and the amount from his aunt is $10,000. Here's one that's not so clean, but we can clean that up. 5% of that amount is what he had to pay back. Okay, so this becomes 0.05x plus 0.014y equals 428. I'm going to multiply everything by 100. 5x plus, I need to go by 1,000 because I need to move this bad boy over 3 decimal places. So this is going to not be 5x. Let's make this 1, 2, 3, 50x plus 14y equals 428 followed by 3 zeros. Equation number 1. Equation number 2. All right, where are my spot checkers? Did I do everything right so far?
I think so.
Okay, that would be good to know. All right, so here's what I'm going to do. I'm going to take this line, 50x plus 14y equals 428,000. I'm going to take this row and multiply by, let's say negative 14. So now I'm going to get negative 14x minus 14y equals negative 140,000. I'm going to do elimination by addition.
Should 74x be negative as well?
I'm sorry, that is negative 14. My negative got a little too close.
Okay.
Yeah. Thank you, though. 36x equals 0, 0, 0, 8, 2, 8. X equals, that might be a calculator one. What does X equal?
8,000.
8,000? 8,000. So that means from Perkins, he borrowed 8,000. And how much did David borrow from his aunt? Well, that one's easy. 2,000. Questions? Questions? Okay, we're going to stop there. Stop the recording.